presentation now, which is from Amy LaBarge, who is also with Seattle Public Utilities, but works in the Cedar River Watershed.
Thank you, Crystal and Paul. Moving from a lot of built assets into a discussion about natural assets in the city's municipal watersheds, both the Cedar and the Tolt. I'll talk a little bit about what we're doing, what our overall management missions are, and how we're incorporating climate change into our work out in the watersheds. So for those of you who are in the plenary session earlier this morning, Rolf Gersonda put up this slide. It basically shows you where the municipal watersheds are that we're talking about in relation to the Seattle metropolitan area. The Cedar River Municipal Watershed is our larger watershed. It does comprise over 90,000 acres, while the South Fork of the Tolt is a smaller, our little sister watershed. We own about 8,000 acres there in the northern part of this slide. They're different in the ecosystem services that they provide and the level of sensitivities that they hold. The Cedar River Municipal Watershed, as Paul mentioned, is an unfiltered supply. We basically filter out the coarse chewable chunks and add some chlorine and fluoride. There is an ozonation process that happens at the Lake Young's reservation, but it's an unfiltered supply, so it has a higher level of exposure, as Paul mentioned. It also is home to a few different species that are listed under the Endangered Species Act, including Chinook and other anadromous fish, as well as an adfluvial bull trout that lives up in the Chester Morse Lake, which is the drinking water supply and tributaries. There are terrestrial threatened species as well, including historically spotted owl and the marbled mirlet, which is a seagoing bird. The South Fork of the Tolt does not provide home to threatened species in the watershed, but there is steelhead down in the lower river system, so we have concerns about stream temperature there. So the municipal watersheds together comprise 100,000 acres of land and water system. The primary reason why Seattle owns and manages this land base is for water supply. And there's a long history of land acquisition, over a century of land acquisition that led to Seattle owning this large piece of land, or two pieces of land in King County. The secondary reasons for managing this land include habitat provision for threatened and endangered species, as well as biodiversity, flood regulation in terms of the water management, and a host of ecosystem processes, including carbon sequestration, nutrient cycling, water cycle regulation, et cetera. Both watersheds, but in particular the Cedar, have very high importance in terms of cultural resources as well, and also, as Rolf mentioned this morning, are very important, in particular, again, the Cedar, for education and research, and we have a long history of collaboration with local educational and research institutions there. Just to point out, there have been discussions about forest hydrology from Susan and others earlier today, as well as Joan and Megan's talk about water supply, which I'm not really going to talk about at all in this presentation, but just to point out that it is largely, they are snow-dependent supplies, and so clearly there are implications there. The watersheds, one may look at them and think that they're pristine because they are largely protected by Seattle. You have to have permission to enter, but really there's a long legacy of management. In the Cedar in particular, of that 90,000 acres, 70,000 is second growth forest. We're lucky to have about 14,000 acres left of unlogged primary forest, which you can see in the picture on the left there, mountain is covered by old growth with the second growth forest all around. And on the right, just a picture of the forest that's regenerated. Small trees, dense forest condition with the legacy stumps and a little bit of hardware left behind by the loggers. So what we're dealing with and my focus as a forest ecologist is protecting and restoring these forest habitats for all of the management objectives that I mentioned. And what we're dealing with is a changed forest condition in the watershed from very structurally complex old forest now to relatively simple forest structure across most of the watershed. The current management approaches, I'll just briefly go over. Our primary goal again is to protect the water supply. On the Cedar, we have the limited alternative to filtration, which is a very unique agreement that we have with the EPA and the Washington State Department of Health. That doesn't apply on the Tolt, where we do have filtration. The Cedar River watershed is managed under a habitat conservation plan because we do have listed species under ESA. So as Paul mentioned, we have some regulatory constraints and management objectives to make sure that we're avoiding harm to these listed species. In exchange for continuing to operate our water supply infrastructure, we have a whole host of mitigation packages under this Habitat Conservation Plan, which is a 50-year plan. And that includes dealing with our legacy forest road system. I'll show some examples of that. Restoring the second growth forest habitats and improving stream and riparian systems, as well as protecting and tracking what's happening with the fish and wildlife species. So it's a very comprehensive plan. The other more recent change in our management is really working hard to incorporate tribal uses. We do have a number of tribes who are interested in using the cultural resources that are in the municipal watershed. So just a picture on the left there of big huckleberry, which is in more limited supply and important to Native people. So we did inherit a bunch of really bad forest roads from all of the logging that was done over the past century in both watersheds. You can see a picture on the upper left there of the clear-cut slope and the road that we are now actively removing about a third of all of the roads that we inherited. At the beginning of the Habitat Conservation Plan in 2000, we had over 600 miles of road to deal with in the 90,000 acre area. We've also been decommissioning roads in the Tolt, which were very bad and caused a huge amount of turbidity, which led us to build the filtration plant. Now we've decommissioned a lot of those roads, and we have greatly improved water quality in the Tolt. So just a couple examples where this is one way in which we're already mainstreaming some management approaches to deal with projected climate change impacts. In particular, some of the road-related infrastructure is dealing with projected peak flows, or what we think we'll be able to handle projected peak flows. So on the lower left, you can see a large peak flow culvert that we put in up at the headwaters of the South Fork of the Cedar River. Very, very big pipe that should handle flows into the future. We're putting in a large pipe is cost prohibitive. We'll then move to a spanning structure like the bridge on the lower right. So just a couple examples of how we're dealing with roads and separating the hydrology from the road infrastructure and getting it back into the natural drainage pathways. In terms of stream restoration, of course, like many other lands, there's been a long history of degradation of stream habitats and riparian condition from logging and simplification of those systems and removal of large woody debris, actively removing large woody debris from streams. So the picture on the left there is of a tributary stream to Chester Morris Lake, which the bull trout species does call home for spawning. And we have a road right next to it, so some of our stream restoration projects are to improve fish habitat, put some wood back into the stream. Others are to increase channel stability. And we also have an active riparian restoration program to get more large conifers and higher function into those systems. In terms of forest restoration, we have about 12,000 acres of active management that we're committed to do under the Habitat Conservation Plan. And really, the goal has been to increase the forest structural complexity and improve habitat for those listed species. So we've done a lot of thinning and we're doing some planting. We're really incorporating resilience ideas and climate change adaptation into both of these programs currently. And we do have active monitoring and research programs. The overall questions that we have of our monitoring programs is to track change over time in both the forest and stream habitats, and also track effectiveness of the restoration programs. It's important that we look back at our monitoring programs and ask how effective is our current management, and also adjust and approach our monitoring, use baseline information that we have, and incorporate more climate-related questions. So there's been a lot of information already on projected climate impacts. I think everything that's been talked about applies to the watershed, but just a few watersheds, a few things that come out really are impacts to flows, which then affects fish habitat, impacts to forest health, and of course the fire piece. So I'm just going to move on from here, talk about a couple examples. We have been working with an advisory committee under the Habitat Conservation Plan, in addition to all of the PUMA work that Paul mentioned, and focusing in on some of the priority impacts and needs for adaptation. So I'm going to focus in on the fire risk and forest resilience and just make a mention of those. In terms of fire risk management, this is something that we need to focus more on in the municipal watersheds. It's a big threat that we have, and so we really need to talk about our level of preparedness. We have done some modeling in the past, looking at potential fire types in the watershed. So the red polygons here show where we have potential for crown fire, which is about 20% of the watershed area. We do have an active wildland fire team, so I think there's some room where we could talk with Seattle City Light and potentially cross-train. This team trains on live fires all over to really improve our ability to suppress fires. But there is a discussion that we need to have about, is there some level of prevention that we need to do in the municipal watersheds in terms of active forest management, protecting our boundaries, increasing resistance potentially to a fire coming in from the outside. And this is an area to really work with neighboring landowners and other agencies. And so this is a task that we'll be working on next year. The other piece to think about is what steps we take to aid forest recovery and getting ahead of the curve in terms of what we're planting out in the forests now to be able to have species that will be able to actually respond to fire. Adaptation challenges in the forest. Really, we talk a lot about managing for resilience. I think the west side forests are a little bit different than a lot of the discussions on east side in terms of fuel reduction and the forest health issues that are happening over in drier forest types. So the west side forests are a little different because they don't have the same level of moisture deficit. But still, we're anticipating alterations in the disturbance regimes, changes in vegetation type, and a lot of interacting variables. How much is just natural disturbance and how much is climate-mediated are real questions that we have in terms of maintaining forest cover to be able to meet all of our management objectives of clean water supply and habitat for the fish and wildlife species and ecosystem service provision. So we are actively managing to shift species composition in some areas to deal with forest health issues that we either have now or anticipate in the future. On the left is just a picture of a root rot pocket, and on the right we are actively planting different species that are less prevalent in the municipal watersheds. So I think with that, I will see if I can take one or two questions. And, yep. Okay. Yep. What kind of chemicals are we using for fire suppression? Well, I don't know exactly what chemicals we would use. I'm not really a fire suppression person, so I would have to refer that question, but I know that we do have the ability to use chemicals. We learned a fair amount from the folks down in San Francisco with the rim fire. There were a lot of discussions about fire retardants and what was appropriate to use in the vicinity of a water supply. We can make a decision to use fire retardants, and that would happen, during the actual process.
Great, thank you. Our last speaker